Our group decided to base our study on the construction of St. Clair Recreation Centre that will include a 6-court basketball stadium, indoor function space and more. We will focus on the framing system used to construct the structure, including how members were delivered and handled on site, possible future improvements to the delivery process and processes of steelwork construction.
Research conducted by 2 authors known as Asaf and Al-Hiji found that the delivery of materials such as structural steel is a major problem for the delay of a construction project. Such delays can be avoided through intricate planning, which stems from key communicative and cooperative methods between supplier and customer. Found that a high number of casualties occur annually as a result of unloading structural steel. The main causes of injuries or casualties included workers falling onto or from vehicles, workers being struck by the steel during mechanical handling, as well as workers being injured during manual handling operations. The delivery of structural steel to the St. Clair Recreational Centre development began with an assessment of the associated hazards between the customer and the client, which should carry out an analysis of reported accidents and significant risks that are associated with the delivery of structural steel. The responsibility of safe delivery is between the supplier, contract hauler, and the customer. Essentially, these 3 parties must ensure that there are correct measures to control the risks of the health and safety of the workers, whose safety is compromised by the delivery procedure. Due to limited space for materials on site, contractors are requested to pre-book deliveries. Those materials are then need to be used in set time frames. Trucks in this site will enter through a gate off Woodville Road, and then the steel is unloaded. Where the steel work is strapped together, special caution shall be exercised when releasing the strapping. In the event where the steel work is stacked on site, the stacks need to be stabilised for safe accessibility, should it be required for workers to handle the stockpile. There has been a push for the implementation of 3D software such as BIM to be used across all design and construction businesses in the industry. Many firms in Australia are developing the new systems which streamline entire project delivery processes in order to achieve cohesive, high quality and cost and time saving projects.
The principles of design behind steel structure framing are mainly dependent on the function of the building with an economic goal to produce it for as cheap as possible. The main sections of the frame are comprised of I-beams with their high strength. They are the main load-bearing members. Universal columns provide the upright columns, whilst universal beams are used as rafters or in multi-storey structures to create flooring beams. Channels and Zs are often used for purlins and girts. Bracing and struts may comprise of circular and rectangular hollow sections, angles and rods. The 2 types of connections used on commercial and industrial steel framed buildings are flexible and rigid connections. Flexible connections make use of cleats and brackets welded onto the web of one of the beams. This allows it to be fastened to the other member via a nut and bolt through pre-drilled holes in either the web or the flange of the second member. With rigid connections, a plate is welded onto the end of the beams, allowing a larger surface area to sit flush with either another beam and end plate or the web or flange. Splice connections are another form of rigid connection, making use of bolted or welded side plates. The other beam is then inserted in between these plates and bolted through, creating a clean end-to-end connection. Angles can be easily connected using nuts and bolts and sometimes only require minor notching. However, CHS and RHS may require further work. Welding a slotted end plate or a T-end allows them to be connected. Small CHS sections can just use a flattened end with holes punched in. The erection process starts with lifting the columns onto the footing pads and tightening the holding down bolts. They are not bolted up as tight as possible, as adjustments may need to be made. Levels are checked as the column is made square and the bolts are tightened. Rafters are lifted into place with bolts being loosely connected until they are all in. Then the bolting up occurs. Bracings, purlins and girts are attached using cleats welded to the beams. Once all structural steel members are fixed, cladding may be attached.